So hi everyone, welcome to my coding channel Coding Learner. So today we discuss about the insertion sort. So insertion sort is the simplest sorting algorithm. It takes the values from the unsorted part of the array and places it at the correct position in the sorted array. So now we move forward. So now we understand how the insertion sort is work. It basically takes the value from the unsorted array and put the element in the sorted form. So basically our loop will be started from the first index because we are comparing the previous one with our present indexed element, and we find that we are named our current indexed element as CUR, and we find that if our previous element is smaller than our current element, then we didn't need to set these values. And now we are take the second index of unsorted array, and we find that these elements are in the unsorted form, and these two elements are in the sorted form. And we find that our current element are where we need to put, and we find that our 45 is greater than our 23, and we need to swap these values and make our the unsorted sorted array in the correct form. We takes the 23 at the our first index, and we swap the 45 to our second index of an array, and we find that from this to this all the elements are present in the sorted form, and our current variable at this position at the third position of the array, and we find that the previous element is smaller than our current elements, so we didn't need to put any swap, or we didn't need required any swapping in the sorted array, and we move for our second half. So it is 18 1 and okay. So in our I is equals to 4, our current variable at our fourth index of an array, and here we find that the current element are smaller than are the previous one, and all we need to swap these values, and we find that where the current element are need to be fit, so that our sorted array is not become unsorted. So we find the 80 a position for the 18 where it fix, and it fix here because 18 is greater than 12 and 18 is smaller than 23. So here first position is best for the 18, and at last at I is equals to 5, our current element is this, and we find that which place is the best place for the current element, so that our sorted array to be assorted. So we finds that our current element are need to be fit at a zeroth position, and all the elements are the sorted now. So that's it. We take the value from the unsorted array and put the element in the sorted array. So we need to maintain the sorted nature at each iteration. So that's it for insertion. So now we learn briefly what the insertion sort will done. So there is the number of the index. So in the I is equals to 1 loop, our current variable is 45. There is a while loop. I initialize the j with I minus 1. Here the value of I is 1, so the j will be pointed at the 0 indexed element, and our j at this position, and we find that if the array j is greater than our current, it is a while loop. So while loop, there is a condition in the while loop. If the array j element is greater than the current array, then we need to swap the values. It means that j plus 1 will be our array j element. So here we find that our array j element is not greater than our current element. So it is a false condition, and we move. So and it finds that here j is 0, then the 45 will be stored at the first index at an array. It remains same, and when the I is equals to 2, our current variable will point at the second indexed element, which is 23, and our j will be I minus 1. Here I is 2, so our j will be pointed 45, and we find that our current element is smaller than our jth element. If it is that, then we entered in the while loop, and we place the arith j plus 1 in indexed element is equals to the arith j element. It means that our 45 will be placed at here, and it is remain 45 because we are didn't change the indexed at j. So here there is no changes occur, and we decrement j by 1, and the j will be at the 0th indexed element. And after that we check again the arith j is greater than our current. So our arith j element is 12 and our current element is 45. So when we compare this, we find that it is the false statement. So it is not 45. Here current variable is 23. I just 23. So our current variable is 23. We find that 12 is smaller than 23. Then we are placed the arith j plus is equals to the current. So we are j current value is 0. Then we increment the jth value by 1, and we find that we are at the first index of an array, and here we place the 23 at this position. So this is how these elements are placed at their sorted position. So when the I is equals to 3, the current variable is 51. So this is our current variable, and we are started the loop from j is equals to I minus 1. Here the value of I is 3, so it's point at the second indexed element, and here 45 is smaller than a 51, or the jth element arrayth element is smaller than our current element. So if the condition is false, then we find that the I is equals to 0 till I is equals to third elements, all the elements are in the sorted form. So we don't need to traverse each element and to find that with where is the 51st position which meet. So now we are go for the next iteration, which is I is equals to 4, and this is the indexing of an array. So we are at the third position. Sorry, we are at the fourth position of an array, and we are having a current variable or element at is 19, and our loop will be started from j is equals to I minus 1. So here we find that the arith j element is greater than our current element. So we need to place the 19 at the right positions, and we are entered in the loop, and we change the arith j plus 1 is equals to array of j. It means that our 51 will placed at fourth position here, and it remains 51. We are already saved the 19 in our current variable. So when after this we are decrement our j by 1, and we are compare our jth indexed, and we find that we are at second indexed, and we are comparing the current with our second indexed element, and we find that 19 is still smaller than 45, so we swap 45 at this position j plus 1, and here j will be decremented by 1, so here j will be at the first position and 45 will be remain same, and we find that if the variable is still smaller than our jth element, yes it is, then we are placed our jth element at j plus 1 array element, and now 23 will be placed at 45. After this our j will be decremented by 1, and now our j will be at these position, and we find that if the array j element is greater than current, our current variable is 23, so here the condition will be false, and we place our 23 at j plus 1. Here j will be at 0th position. When we incremented it by 1, we find that we are at the first position, and we place 19 at here, and we are find that after the third iteration all the elements are placed at the sorted form till fourth element here. So at the end we are placed the last element at their current position. So that's it. Now we'll look for the brute force approach. So there is int I is equals to 1, where the outer loop will be started, and we place or save the element at the current variable, and we initialize our jth variable with I minus 1. It means that the previous one, our I will be, if the I will be 1, then our j will be 0. J will be 0. So this loop is the backward loop. The j loop will be backward loop, and we check if the current variable is smaller than our array, so we entered in the loop and we swap all the values and placed our current variable at the current position at the end. And there is a condition over here. We take care that the j will be greater than equals to 0. If we are not putting these condition, our get the wrong values in our data, which we all didn't know, because so I already created an array of six element, and we having int n, which is the number of the element, and we are do the insertion sort. So there is a for loop which is started from I is equals to 1, and it goes for I is smaller than n, and each time the I will be incremented by 1, and we are store our ith index in our int current variable, so we store it, and we having a while loop. Before while loop we initialize the int j will be I minus 1, so it is the backward loop. So while there is a condition, if the array j element is greater than our current variable, and there is a condition, if we are didn't put the j is greater than equals to 0 condition, we get the garbage value, which is affects our result. So at first the j I plus 1 value will be our array j value. We swap the values by one by one, and we decrement our j, and after the while loop we are placed the current element at their correct position. So that's it. There is a for loop which goes 0 smaller than n, and I will increment it for printing the element of an array. array I11 with space. So that's it. While splitting array react semicolon. Okay. So we got the array in the sorted form. Let's see what is happen at each example. So we are check before the decrementation of our jth value variable. What is happening here? So let's see. Save it. Okay. Okay, there is no requirement to enter the loop, so it's prints as it is, and we save the values at the second times with 45 and 23. So we are placed the 45 at g plus 1. That's why we getting a 245 at this value, and we find that if the our current element is greater than is greater than our jth element, then we increment the j and we place the current variable at g plus 1. So this is how the process are going, and at last we find that our element are placed at the correct position in the sorted form. So that's it. For more shorts or videos, please like, share and subscribe.